Hello everyone, my name is Zvonimir Nevistic and I'm coming from the Faculty of Geodesy, University of Zagreb. And today I will present to you a paper entitled Economic Aspects of UAV Application in Change Detection Monitoring, which I made in collaboration with Professor Željko BAČIĆ, also from the Faculty of Geodesy in Zagreb. I hope you will find our paper interesting and that will give you some useful information for the future work. So we can start. Unmanned aerial vehicle systems are nowadays widely used, especially in application where aerial imaging is an important source of information for performing certain tasks. With the advancement of technology, UAVs have reached an inviolable level of practical reliability and functionality that has enabled this system to enter the geometric business market. One of the potential applications of UAV's images is the change detection on the Earth's surface by recording a series of images of the same surface over the time, which is a great interest of the numbers of applications. This paper will show how the UAV images can be used to monitor smaller sites, to monitor green urban areas and their application in agriculture, together with the economic aspects of performing certain tasks. Unmanned aerial vehicle or drone are aircraft either controlled by pilot operators from the ground or from a pre-programmed mission. In the past, UAVs were used exclusively for military purposes, but today drone systems are very easy to operate and are increasingly used for the commercial purposes. As you can see from the list on the right, there are numerous types of drones classified by the weight and the range, and they can be from micro and mini UAVs to big combat aircrafts. Remote sensing tools have been used as successful environmental monitoring resources. With the emergence and the ability to carry remote sensing tools, drone technologies are being increasingly recognized for these tasks. The data retrieved by drones can be used quickly to prove up-to-date, high-spatial, area-wide and cost-effective transformation of data or images for mapping of environment. Because of all mentioned, professionals and researchers are turning to drones in place of slower terrestrial surveying equipment, lower resolution satellite imagery, and expensive and sometimes unavailable manned aircraft services. On the right, you can see just a few examples of how the drones can be used in environmental monitoring. UAVs must meet some basic requirements in order to be used for environmental monitoring and change detection purposes. The basic requirements are the possibility of performing the designed flight plan with a high accuracy, also possibility to carry equipment for recording and navigation, aircraft flight autonomy, and reduction of vibration and other external influences during the flight. The most commonly used sensor on drones for aerial imaging are RGB cameras, lightweight multispectral, hyperspectral, and thermal infrared sensors, and also the LIDAR sensors for most accurate ways of geometric data acquisition. The aircraft additional equipment includes GPS and inertial system, camera stabilization system, and other sensors such as barometer, thermometer, and others. With a built-in GPS unit or IMU, other sensors and stabilizer, UAVs allow image acquisition following a predefined path. Such platforms usually have some advantages, such as that UAV is able to work in a relatively confident space with higher reliability. Images can be taken in discrete mode and can effectively avoid motion blurs. And the flight path can be pre-programmed according to the expected overlaps and resolution. When recording with drone, each procedure consists of these three basic steps. First step is pre-flight planning, which must be done in the way that we gather all the necessary information in as few overflight as possible, and we must include all requirements. Second one is performing flight operation, and the third one is data processing, where many softwares offers user-friendly and low-cost alternative to conventional digital photogrammetric processing. And nowadays, there are many open code softwares to meet processing requirements. As we already said, drones have many applications in environmental monitoring, and one of the most common use of it is the change detection on the Earth's surface, which should be analyzed through certain units using segmentation technique. Change detection as a very important application in remote sensing may see many opportunities and unexplored application looking at much finer spatial scales, such as the detection of illegal waste dumping, street facility misplacement, and crowd anomaly detection. And now, as you can see on the right side, let's see some other application of drones in environmental monitoring as listed here. In agriculture, drones are most commonly used in precise agriculture, which requires mapping the spatial variability of as many variables as can be measured. Drones are used because of their high operability, which gives them perspective of ultra-high spatial and temporal resolution and free of cloud occlusion as well. They can be used for soil and field analysis, crop monitoring, health assessment, and many other applications because they are able to produce 3D maps quickly and cheap, which are then used for the design of seed planting patterns and can generate a wide range of the data types for many applications. They can also monitor crops much more accurately, frequently, and affordably, and drones are able to generate multispectral images of crops for further analysis, and then can identify parts of the field with hydric stress. Also, they can easily adjust the altitudes and flight paths according to the surrounding topography and geography. In addition to these mentioned advantages of drones in agriculture, they can also be used in forestry, where they can provide the possibility of making a non-destructive and accurate measurement of many attributes of trees. They can, for example, be used for estimation of dendrometric parameters or estimating tree height, crown width, and basal areas. Drones has opened up new opportunities for monitoring and managing natural ecosystem. They have potential to monitor a wide range of habitats and location, and researchers have been using drones to monitor attributes such as plant population, biodiversity and species ranges, plant species invasion, land cover, land changes, and many others, other applications. In water management, UAVs can be used for monitoring sea level, beach erosion, monitoring of river system, and floods. And in disaster management, they can be used for pre-disaster preparedness, disaster assessment, and disaster response and recovery of wildfires, flood, earthquakes, and other natural and man-made disasters. They can create before and after maps of impact area. I can save, assess to damage infrastructure. And also they can help in search and rescue segment and many other applications. In our case study, two recordings were made at two different locations, investigating the economic aspects of those recordings. And the EB AirTech drone was used for both tasks. The first study included surveys of the Marian Forest Park in Split with an area of 10 square kilometers with a requirement of pixel size of less than 20 centimeters. The flight plan included the influence of the wind and the required accuracy, and the maximum flight duration is 40 minutes. The longitudinal overlap is 70 and transverse 75%. The final result is orthomosaic or 3D model. The number of overflights required to achieve this accuracy is 18, which means that the entire area can be recorded in 2 working days. Process was done in Terra 3D software. In second case study image of archaeological sites of area of 0.14 square kilometers was recorded with the required pixel size of maximum of 5 centimeters. As in the previous study, all elements were included in the planet, and the longitudinal overlap was reduced of 50%. Recording takes only 11 minutes, and the result is a 3D model with a pixel size less than 5 centimeters. But what is our interest is economic aspects of these kind images. In the first table, you can see the approximate prices of such jobs in the Republic of Croatia. As we can see in the both cases, the total cost of drone shooting is significantly lower than the classic survey. As for smaller sites like our archaeological one, for a classic survey, it would be necessary to collect several projects in order to the job to be profitable to the company that does it, because otherwise they wouldn't go even to the field. In addition to the above prices, there are also some other economic advantages, which you can see in the table too. The production time is reduced, less people are needed, for less money we can get a higher resolution, and the processing time is significantly shorter, and most importantly, it is available to the everyone. But as other measurement methods, there are some challenges with drone, like environmental challenges related to the terrain and topography and meteorological conditions that can cause noise problem. There are also the data, big data problem, because this type of data are extremely large and you need the good software and stable and strong computers, and also it is necessary to be responsible for all things that happen during the flight, and there are also some data privacy issues and flying regulation that vary from state to state. But despite that, we can conclude that the drones can greatly contribute to the environmental monitoring, and they reach an inviolable level of practical reliability and have many advantages to operate in the repeated data collection over changing areas. However, their role as a low-cost airborne platform has not been fully utilized, although they are competitive in the term of economic aspects to other measurement technologies. Implementing drones will change environmental monitoring and increase speed of data collection. They will improve aerial surveys and base map and enable better situational design, as well as the production of the better 3D visualization. So this is all from us. Here is our list of references. And if you have any questions about this topic, feel free to contact us. And thanks you for your attention, and best regards from the Zagreb.